isomerism. Okay, we are going to discuss about here optical isomerism. Optical isomerism. So we discuss about the geometrical isomerism and optical isomerism. Okay, actually geometrical and optical isomers are both they comes under the configurational isomers. Okay, so configurational isomerism is classified into two types. So one is geometrical isomerism, another one is here optical isomerism. Sir, what is meant by the optical isomerism means? First, before going to the optical isomerism, first we have to know some terms. What are the terms we have to know means optically active compound. The first one is here optically active compound. Optically active compound. So what is meant the optically active compound, which we can call as a optically active compounds? Optically active compounds are called here, so which we can call as optically active compounds means the compounds which contains which contains chiral center, chiral or asymmetric center, chiral or asymmetric carbon, chiral carbon or asymmetric carbon. Okay, the compounds which contains chiral carbon or asymmetric carbons is called as a optically active compounds. Okay, so it's called optically active compounds. Optically active compounds. Optically active. So what is mean by the chiral? Here you got us a doubt. Okay. So generally we'll get as a doubt here. So what is meant by the optically active? Yeah, chiral. So what is mean by the chiral? What is mean by chiral? Sorry, you wrote as a chiral or asymmetry. Okay, asymmetry. So what is mean by the chiral or asymmetry means here? The carbon which is attaches with the four different atoms or group of atoms is called as a chiral carbon. That is only we can call as a asymmetry. Okay, so simple. Okay, so here what is a simple thing means? Actually in Greek word, chi means hand. Chi means hand. So both of you once you check it out our hand is having different size of the finger. What are the fingers are there to our hand? All are same size or different size? It is same size or different size, ma?
Different.
Different size. Okay. So according to that one, let us see. So according to that one, how we can define the chiral carbon means in Tamil and Kannada also. In Kannada also, kai means hand only. In Tamil also, kai means hand only here. So chiral is a Greek word. According to the Greek word, here the carbon which is attaches with the carbon which is attaches with four different atoms, four different atoms or group of atoms is called chiral. Okay, is called chiral here. Okay, sir, how we can represent the chiral? And chiral means here how we can write the chiral and at all means let us see simple representation how we can give means here C is the carbon. What is the carbon valency, ma? What is the valency of the carbon? What is the valency of the carbon, Aditi? Samhita, what is the valency of the carbon?
4, sir.
4.
4 mark. So carbon is having here tetravalency. Tetravalency means here 4. Okay. So carbon is attaches with the 4 different atoms or group of atoms. So if it is attaches with the 4 different, for example, here A it is there, here it is B it is there, here it is C it is there, and here it is D it is there. Okay. Now the carbon is attaches with the 4 different atoms or group of atoms. The carbon which is attaches with the 4 different atoms or group of atoms is called as a chiral carbon. Okay, and this is also we are calling as asymmetric. Sir, why we are calling as asymmetric means here if you divide in any direction. Okay, what is meant by the symmetry mean? First of all, symmetry means you will get as a 2 equal halves now. Asymmetric means you need not to get as a 2 equal halves. So if you divide in any direction, if you are not getting 2 equal halves means that we can call as a asymmetry. Okay, so that we can call as a asymmetry. Now you got the clarity? Okay, so which we can call as a, so optically active compounds means the compounds which contain the chiral carbon or asymmetric carbon is called as a optically active. Sir, what is meant by the chiral means the carbon which is attaches with the 4 different atoms or group of atoms. And one more example, if you see our hand, if the hand is cutted in any direction, are you getting 2 equal halves? Is
No,
it
sir.
possible? No, my here. There is no possibility to is there to get as a 2 equal halves. Okay, so that is only we can call as a optically active. And what is we can give another definition. Sir, what is the another definition we can give to explain? So optically activity means here. So in this one, non-superimposable mirror images. The compounds which are having non-superimposable mirror images, those also we can call as here optically active compounds. So what is another definition we can give means here? The compounds which are non-superimposable mirror images, which are non-superimposable, okay, non-superimposable mirror image. The compounds which are having non-superimposable mirror images, non-superimposable mirror images are called optically active compound. So generally the compounds which are having non-superimposable mirror images are called enantiomers. So generally, so the compounds which are non-superimposable mirror images are called as a enantiomers. If the superimposable mirror images are called as a diastereomers. Diastereomers are optically inactive. So which are optically active means here. So non-superimposable mirror images. Now I give 2 structures. If you see means I had given some alphabets. Okay, if you see means one is A, it is there, another side B, it is there by here. Okay, so one is having A, another one is having B. Okay, so in this one, so which one is optically active and which one is optically inactive? So which one is optically active and which one is optically inactive? Aditi? Aditi, which one is optically active and which one is optically inactive? Samhita, here A and P are there.
Sir, if they're not superimposable, then they're optically active.
Which one is optically active?
Non-superimposable.
So the non-superimposable.
Okay, non-superimposable. Now here they had given two alphabets. One is the A, another one is the P mark. Okay, one is the A, another one is the P. It is that. Okay, so which is having the non-superimposable mirror image? Either P or A. That means Aditi. So this is our one hand. So this is our other hand. Okay, so these two are the mirror images actually. These two are mirror images. If we keep side by side, they look like as a mirror images. Okay, now let's see. If I'm going to place like this side if you see means position of the fingers. If you turn this side and if you turn this side also, the position of the fingers is same or different? Position of the fingers is same or different? You wrote it hand side also, this side also. Position of the fingers is same now. If the position of the fingers is same means that we can call it as a diastereomers. Now same one. This is the one hand and this is the another hand. When I'm going to be superimposed on the another one. Now if you clearly you can see the video means here. So is the finger position of the fingers is different or same now? Thumbs. Position of the thumb is different or same? Two thumbs. Samhita. So different only na?
Yes, sir.
Okay, that means so this one is not superimposable. Okay, so non-superimposable mirror images are called as an enantiomer. Superimposable mirror images are called as a diastereomers. Now, in this one, if you see means here, so P is the non-superimposable. Sir, how it is means exactly if you take the P and whenever you're going to place it on the P means, okay, so they are non-superimposable. And if you check it out the A means we are lifting like that. At the same time, we are placing upon the A. So that means position of the A is same. Okay, these two ends are same. So that's why this we can call as a superimposable. Okay, and I'll give one more examples also, which to make you understand I'll give here. Now I'm taking as a U mark. U. If I'm writing as a capital U, the mirror image of U. How we can write? We can write like this also, na? Okay. Now, is U is optically active or optically inactive? My question is, I had given mirror images of the capital U. Is capital U is the optically active or optically inactive? Samhita or Aditi? Is U is optically active or optically inactive? Aditi.
So voice is breaking. Can you repeat?
So capital U is the optically active or optically inactive?
Sir, it's optically inactive because it's superimposable.
Very good, ma. It is optically inactive. It is optically inactive. Okay. So now I'm going to write one more ma here. Capital V I'm taking here. Capital V. Is capital V is optically active or optically inactive? Capital B. The mirror images of this one, we can write like this. Optically active or optically inactive?
Sir, optically active.
So because of non-superimposable mirror images. If the non-superimposable mirror images means that is here optically active. Okay. Non-superimposable mirror images. Okay. So non-superimposable mirror images are called as here optically active. So now you got the clarity. So which we can call as optically active compounds means the compounds which are having chiral center are enantiomers. So those we can call as optically active compounds. And one more statement also we can give for the optical activity mark. Okay. So what is meant optically active compound means here the compound which does not exist elementary elements of symmetry. The compounds which does not exist elements of symmetry. Elements of symmetry. Okay, sir, what is meant by the elements of symmetry means here we have a different types of the symmetry. In this one is called as a plane of symmetry. So plane of symmetry. Okay, so which we can call as a plane of symmetry means here if you divide it with any direction in any plane, if you are getting two equal halves means that we can call as a plane of symmetry. So what is the example for that one means I'm taking as a mesotartaric acid COOH and here HOH and here HOH and COOH it is there. Okay, so actually, so this we can call as a mesotartaric acid. Mesotartaric acid. Okay, so mesotartaric acid is optically inactive. Sir, how you are telling that this optically inactive means it has a plane of symmetry. If you cut in this plane, so if you cut in this direction means you are getting as a two equal halves. Whenever you are getting as a two equal halves means here that time it becomes as a optically inactive. Okay, so it exhibits as a symmetry. If it is exhibits as a optical symmetry means here, so that we can call as a optically inactive. Optically inactive. Okay, and another one also it is there. So what is another means here? Center of symmetry. Center of symmetry. Center of symmetry. Sir, what is the example for the center of symmetry means here? So one second, I'll draw one example. I'll take as one example. Yeah. Are you able to find the structure? Are you able to see or not? Otherwise, I'll draw the structure. Let us see if I'm drawing the structure here. C bond CH3 bond CH3 bond NH bond CO bond C bond H here NH bond CO bond it is that, right? Okay, so now I'll write some small modification by here. CH3 bond CH3. Now we can check it out. Here. So this is the one structure they had given. Okay, either the given compound is optically active or optically inactive, ma. Either the given compound is optically active or optically inactive. Samhita or Aditi. Is the given compound is optically active or optically inactive?
Sir, it's optically inactive.
Very good, ma. Aditi, this optically inactive. Sir, how you are telling that optically inactive means here it has a center of symmetry. Sir, what is meant by the center of symmetry means here if you divide from the center, if you divide from one center means you are getting as a two equal halves. Okay, if you after dividing that one, if you check it out means you are getting as a two equal halves. Whenever you are getting as a two equal halves means then it becomes as a optically inactive. Optically inactive. Okay, and axis of symmetry one it is there. Another one, axis of symmetry. Sir, what is meant by the axis of symmetry? Axis of symmetry means we are having x-axis, y-axis, z-axis. Actually, solid substances are they having the three-dimensional structures. Okay, solid substances are they having the three-dimensional structures. In that one, if you see means how they are getting as a three-dimensional structure means constituent particles are arranged in a three-dimensional manner. Whenever they are arranged in a three-dimensional manner, then only you will get as a three-dimensional structure. So, if you cut in any direction, either along with the x-axis, what is the best example means cube is there. All of you have seen Rubik cube. Everyone you are playing now. Rubik cube is there. So Rubik cube, if you cut any along with the any axis, either maybe x-axis, y-axis, or z-axis, you are getting as a two equal halves. Whenever you are getting as a two equal halves, means Rubik cube is optically inactive compound. Okay, Rubik cube is here optically inactive. So that means the substance which attains axis of symmetry, that it becomes as a optically inactive. Sir, which we can call as a optically active compounds means the compounds which does not exist elements of the symmetry. So that compounds are we can call as a optically active compounds. The compounds which does not exist elements of symmetry is called, okay, optically active compounds. Optically active compounds. If they exist means any kind of symmetry means that optically inactive. Now you got the clarity, sir? The next concept. So what is the next point we have to know means here? So here next concept is plane polarized light. What is mean by the plane polarized light? Any idea? Samhita or Aditi? Actually, this is very important concept. Okay, so this is very important concept. Same concept we are going to study in 12th standard haloalkanes, haloarenes chapter now. Okay, same concept we are going to study in 12th standard haloalkanes, haloarenes chapter. Okay, there we are studying here. So what is mean by the plane polarized light? Plane polarized light. So what is mean by the plane polarized light? Sir, what is mean the plane polarized light? So normally we are taking as a normal light. So is normal light is moves in all the direction na? Normal light is moves in all the direction. Normal light is moves in the all the direction. When the normal light is passes through the nickel prism, through nickel prism, nickel prism. Okay, so nickel prism is made up of calcite. Calcite. In this one, calcite is nothing but calcium carbonate. Calcite is nothing but calcium carbonate. So when the normal light is passes through the nickel prism, light is moves only in one direction. When the light is moves only in one direction is called as a plane polarized light. Plane polarized light. That we can call as here plane polarized light. Plane polarized light. So which we can call as a plane polarized light means the light which travels only in one direction is called as here plane polarized light. So now you got the clarity, sir. So before going to the optical isomerism, first we have to know which one is optically active compound and what is with the plane polarized light. Now we'll go for the optical isomerism. Okay, so now we know the basic terms. Without basic terms, if you study means every time you will get as a confusion mark here. Okay, now optical isomerism. Sir, what is mean by the optical isomerism means here when the plane polarized light, plane polarized light is passes through optically active compound, aqueous solution of optically active compound, optically active compound. The compound rotates plane polarized light. The compound rotates plane polarized light either the direction in either direction. So the direction is either it may be rotates the clockwise direction or anti-clockwise direction. Okay, so whenever it rotates the clockwise or anti-clockwise direction means we are getting as two isomers, two new structures. The two new structures only we can call as a isomers. So that only we can call as a optical isomers. And the phenomenon is called as a optical isomerism. Sir, what is meant the optical isomerism means when the plane polarized light is passes through the aqueous solution of optically active compound. The optical active compound is rotates the plane polarized light either the direction. Okay, sir, what are the directions we can take means here? Now let us see. Condition 1. Sign this one. If the plane polarized light is rotates in clockwise direction, this we can call as here clockwise direction. If it is rotates in clockwise direction, that we can call as a dextro-rotatory. Okay, so dextro-rotatory can be represented with small d. This is also we can represent with positive sign. Okay, so compound is rotates the plane polarized light in a clockwise direction. If it is rotates clockwise direction means you will get as a dextro-rotatory. Okay, and if the plane polarized light is rotates in anti-clockwise direction, plane polarized light is rotates in anti-clockwise direction. If it is rotates in anti-clockwise direction, that we can call as a levorotatory. Okay, so how we are going to represent the levorotatory means levorotatory can be represented with small l or we can represent as a negative sign. Okay, levorotatory can be represented as here, so negative sign or we can represent with the small l. Okay, here, sir, optical isomerism is experimental basis. It is not the theoretical basis. Okay, it is completely experimental base. So by seeing the structure, it is not possible to find out whether the given isomer is dextroisomer or levoisomer. Sir, how we can explain means here? So based on the experiment only we can call as a, we can find out D and L isomers. Okay, now you got the clarity, Aditi? Sanmita, do you understand? What is the name of the instrument we are using? What is the name of the instrument we are using to find out the optical isomers means? Polarimeter. So what is the name of the instrument we are using to find out the optical isomers means here polarimeter. So now you got the clarity, all of you. Okay, right, sir. Aditi, do you understand until here? Aditi, when we can call as a dextroisomer?
Sir?
So when we can call as a dextroisomer?
I don't know.
When we call dextroisomer? Samita? I think so. Leave it. Here only this, sir. So when we can call as a dextroisomer, when we can call as a levoisomer?
Sir, dextro means like when we are going clockwise or towards right side, and anti-clockwise it's
Levorotatory, correct only. So clockwise direction means you will get as a dextrorotatory. So dextro is nothing but right hand. Levo is nothing but left hand. So levo is nothing but here left hand. Okay. So now you got the clarity of the and
so can you hear me?
okay. So I will update this one PDF file. Okay. Now only. After finishing of the class, I will update to the PDF file. Notes. Is that clear? Right now. So here, next term is the specific rotation. Specific rotation. Specific rotation. Specific rotation. Sir, what is meant by the specific rotation? Specific rotation can be represented with alpha. Specific rotation can be represented with alpha. Sir, what is meant by the specific rotation means by passing the plane polarized light on optically active compound. Optically active compound is rotates the light now. How much direction it is rotating? Okay, how much direction it is rotating? That angle only we are calling as a specific rotation. Okay, so by passing the plane polarized light on the optically active substance, it rotates, either it may be rotates the clockwise direction or anti-clockwise direction. Okay, so it rotates means some angle. That angle only we can call as a specific rotation. Okay, so how we can calculate the specific rotation means specific rotation can be represented with alpha. Specific rotation is equal to theta divided by C into L. C into L. So in this one, so theta we are taking as a T and this one we are taking as a lambda. Okay. So in this one, what is meant by the theta means theta is nothing but observed rotation. Observed rotation. Okay. And in this one, C is nothing but concentration of the solution. C is nothing but concentration of solution. Sir, how much concentration we are taking means here? Concentration means already you know, sir, we have some concentration terms. Okay, so molarity, molality, normality. Okay, so how much concentration we are taking means here? If 1 kg of solute present in, so decimeter cube of the solvent. Okay, so 1 kg of the solute is presenting 1 decimeter cube of the solvent. That much of the concentration of the solution we are taking. In this one, length. So L is nothing but length of the polarimeter tube. Length of polarimeter tube. Polarimeter tube. So how much length we are taking means 1 decimeter cube of polarimeter tube we are taking. Okay, in polarimeter instrument, how much length of the polarimeter cube you are taking means 1 decimeter cube. And this one, T is nothing but temperature. Temperature. And lambda is nothing but wavelength of the light. Wavelength of light. Which light? So plane polarized light. Okay, so if we substitute all these values in the above equation, okay, if we substitute all these values in the above equation, means we can calculate the specific rotation. Now you got the clarity, all of you? What is the specific rotation means? By passing the plane polarized light on the optically active compound, the substance it rotates the plane polarized light some angle. That angle only we are considering as a specific rotation. Okay, so specific rotation can be calculated by alpha is equal to theta by C into L. Clear? And factors. What are the factors affecting the specific rotation? Factors affecting specific rotation. Factors affecting specific rotation. Specific rotation. Sir, what are the factors affecting the specific rotation means here? So one is nature of the solute. So first one is nature of the solute. Nature of solute. Second one is nature of solvent. Nature of solvent. Third one is concentration of solution. concentration of solution. Okay, and fourth one is temperature, and fifth one is wavelength of light, okay, and last one, 61 is length of the polarimeter. 61 is here, length of polarimeter tube, length of polarimeter tube. So all these factors are affecting specific rotation. Okay, Aditi, what are the factors affecting the specific rotation, ma? It is the surface power. Okay, so right now. So Samhita, so what are the factors affecting the specific rotation means here? Nature of the solute, nature of the solvent, concentration of the solution, temperature, wavelength of the light, and length of the polarimeter tube. Okay, so based on we are having some of the questions. In next session, we are going to discuss about that questions. Until here, all of you understood now? Okay.